Hi, welcome to my video. So I'm just going to start by just reading it. By definition, the capacitance of this equivalent capacitor is, so this paragraph is on deriving the parallel capacitor's equation. So this equation right here, we can see that, so we know that to calculate capacitance, it's charge divided by voltage. So we got that by so this is Q, this is charge, this is voltage, and then like the slope is the capacitance. And as the line gets steeper, the capacitance is bigger. So also, since this is about parallel circuit, we know that in a parallel circuit, the voltage stays the same. And current add up to the total current. So right here we can see that the voltage stays the same since it's in a parallel circuit, and then you add up the current. So current is essentially charge over second, so coulomb over second. So you just add up Q1 and Q2, and then after combining them and like do some math and algebra, you get like this equation. So C equals C1 plus C2. Oh, it's C total right here. So this analysis hinges on the fact that parallel capacitors each have the same potential difference. We could, like I said right here, we could easily extend this analysis to more than two capacitors. If capacitors C1, C2, C3 are in parallel, their equivalent capacitance is, yeah, so this is the equation for parallel capacitors. Neither the battery nor any other part of a circuit can tell if the parallel capacitors are replaced by a single capacitor having capacitance C equivalent. So this is saying that, for example, if you have so this is a circuit with, oops, hold on. Let me just draw in real quick. Wait. So it's saying that you can always replace these two capacitors with an equivalent capacitor. Like so you can basically add these two, like add these up and like use a bigger one. So it's saying that this is the same thing except with a greater capacitance. And we just have to find out like what exactly, like what the capacitance, the total capacitance of these two capacitors is, so we can replace it with this big one. So yeah, and then on to the question. So right here we have a question about a related question. So we're looking at this one. So we have two parallel capacitors right here, and then this one is in series with these two. So first we have to find the capacitance of these two parallel capacitors. So I'm just gonna write C parallel equals just 20 plus 10 equals 30 microfarads, and then so these two is essentially 30 microfarads, and then you use the formula for series capacitors, or which is the total capacitance here, and that equation is C1 plus C2, and then inverse it. Okay, and so it's equals to 1 over 10 plus 1 over 30. inverse it, and then let me plug in my calculator. That equals 7.5 microfarads. So that's 7.5 is the total capacitance of all three capacitors combined. So essentially, you can replace it with one big capacitor instead of those three, and they will be like it will be exactly the same thing. Like this one has 7.5 microfarads. Yeah, thank you for watching.